Okay, so welcome to section 7.3, which is absolute value equations. In 7.1 we talked about absolute value operations, and section 7.2 we went over how to graph absolute value functions. Okay, now we're going to talk about the equation. So first off, you're going to have to recall the definition of an absolute value, okay, which I have down here. How we consider basically the positive and the negative of the inside expression. Okay, this would be our case 1 and case 2. So let me give you an example. Say I had this absolute value equation, okay, something like this. You'd actually have to consider two cases here. When you have x minus 2 equals 2x, and when you have negative x minus 2 equals 2x. Okay. The conditions that you're going to consider is when the inside, the complete inside, is greater than or equal to 0, and when the inside is, or the negative is less than or equal, or is less than 0. To do this, you're going to take a look at x minus 2 equals 0 and solve this, okay, to get u x equals 2. On either side of x equals 2, the expression will either be positive or negative. Okay, so suppose you plugged in 3 into x or 4 into x, then this whole expression would be positive. Okay, so really I'm trying to find these guys. Okay, these are the conditions. Okay, these are the conditions, which is something you have to discover before you do the question. In my example here, if x is greater than or equal to 2, this expression will be positive. If it's less than 2, then it'll be negative. You can see that if I put in 1 right here, you're going to have a negative expression inside the bracket, inside the absolute value. Okay, so I'm going to walk you through how to do all of this. So here's the first example. You can take a look at the solution in the notes. I'm going to do the practice problem associated with it. So here we go. 6 minus x equals 2. The first thing I'm going to do is I'm going to simply write out the definition, okay, which is 6 minus x and negative 6 minus x. Okay, the question is, what are the conditions? To find the conditions, you are going to solve, and this is going to be a general way of doing this, you're going to solve the expression equal to 0. Then you're going to look at both sides of your solution to see when it's positive or negative. Okay, so in this example, you can see right away that x is equal to 6. So the question is, here's the question. If I was to plug in values greater than 6, back into this, would I get negative values or positive values? Okay, so perhaps you can use test values. So for example, if I was to use 6 minus, say, 7, that would be negative. You can already see by induction this is going to continue to be negative. So therefore, as long as x is greater than or equal to 6, right? Or I should say, as long as x is greater than 6, you're going to have negative values. If it's equal to 6, you're going to get 0. So it's going to be negative here when x is greater than 6, right? It's going to be 0 or positive when x is less than or equal to 6. Okay, that's how you find the conditions. Okay, once you find the conditions, you can move on to your cases. So case 1 and case 2. Case 1 is solving the following. 6 minus x equals 2. Okay, that's case 1. Which you can see quite quickly what this is going to come out to be. We're going to have 4 equals x. Right? X equals 4. What I'm going to do right away is check the conditions. Okay. I should say is. Okay. Is 4 remember, we're doing this one right here. Is 4 less than or equal to 6? Yes. Therefore, now we have to check. Okay, now we have to check if it satisfies the original equation. We're going to have 6 minus 4 equals 2, and you are going to have absolute value 2 equals 2, which is true. Okay? The next one we have is negative open bracket 6 minus x close bracket equals 2. In this case, you're going to have 6 minus x equals negative 2. So you're going to have negative x equals negative 8. So x is equal to 8. And once again, is 8. Now we're looking at this guy right here. Okay, less than 6. Not sure where this thing came from. Is it greater than 6? Sorry. Yes, it is. Now we move on to check. So you always check the conditions first, then you plug it back in. Okay? Then you plug it back in. This is going to be absolute value negative 2 equals 2, which will be correct. Okay? Therefore, your solutions are x equals 4 and x equals 8. Okay? So, let's move on to a word problem. You can look through the first word problem I did for you in the notes, and here's the second one. A computerized process controls the amount of fish that is packaged in a specific size of can. The computer program sets the ideal mass at 170 grams, but allows a tolerance of plus or minus 6 grams. Solve an absolute value equation for the maximum and minimum mass of fish in the size of can. So basically, if I was to draw a number line, the ideal mass that they want is 170. However, they're allowing a plus or minus, okay, 6 range. So really the minimum value and maximum value will be 170 minus 6, which will be 163 grams, and 170 plus 6, which is 176 grams. That is actually the answers to this question. But let's go through how you would set this up as an absolute value equation. Suppose you have a more complicated example, or suppose you want to tell a computer to do this, right? You did this by looking at, or we did this by looking at a number line, basically doing it by inspection. However, how would you tell a computer to do this? When you quantify this question, you're actually going to use an absolute value, because what you're interested in is you're interested in the following. That's what you're interested in. This is the mass, and you want it. You want the maximum or minimum. You want the distance from 170 to be a maximum of 6. Notice how I use the word distance. Okay, so that's the mass, and the distance is always positive, right? The distance from here, from 163 to 170, is positive, and the distance from 176 to 170 is positive 6. So that's the difference. That's the distance. So you can solve this equation, okay? Just like that. In this case, we have m minus 170 equals 6. Therefore, m is going to equal 176 grams, or m minus 170 equals 6. Therefore, m is going to equal 163 once you work this out. Okay, so that's how you tell a computer to do it. Remember, you can define to a computer the definition of absolute value. Therefore, it would go through this for you, and it would pump out a solution. So now let's go back to solving some more cases that can arise in absolute values. You can often get extraneous solutions. That basically means when you solve an absolute value, you can have some solutions that don't satisfy the original equation or that don't satisfy the conditions. Okay, and when I mean conditions, I mean these guys right here, which is what happens in the example I give you. So when we go through the practice problems, the first thing you do is write out the definition. And walk yourself through what the values would be. Okay. In this case, when you solve x plus 5 equals 0, x is going to be equal to negative 5. Okay. If you put negative 6 in for here, you can see that's going to be negative 1. Right? Negative 7, that's going to be negative 2. So when x is less than negative 5, you're going to have negative values. If x is greater than or equal to negative 5, you're going to get 0 and above. Okay? So let's keep that in mind. Oops. So let's solve case 1 and case 2. So case 1 will be x plus 5 equals 4x minus 1, which will come out to be 6 equals 5x. Sorry, 3x. Sorry about that. Which means x is going to be 2. Now, is 2 greater than or equal to negative 5? Yes, it is. Therefore, we check. We go ahead and check. 2 plus 5 equals 4 times 2 minus 1. That comes out to be absolute value of 7 plus or equals 7, which is correct. So 2 is a solution. Okay, no matter what. Moving on to the next section, the next case, we have the following. And when we solve this, what do we get? So I'm assuming this is all comfortable for you. Negative 4 over 5, which is really equal to negative 0.8. I'm going to use the decimal so I can compare it more easily with this condition. Is that true? Is negative 0.8 less than negative 5? No. Therefore, extraneous solution. And therefore, your only solution is x equals 2. Okay? So, that's an example of how you can get an extraneous solution. Basically, there's no difference between what we did in practice problem 1 and practice problem 3. Okay? I'm just pointing out to you what you would do if something didn't satisfy the solution. You just disregard it. Now, of course, the second, actually we're going to do 3 more examples, but you can also have an absolute value equation that has no solution. Okay? No solution at all. Nothing would satisfy the equation. And typically this happens whenever the right-hand side is negative, when the absolute value function is isolated. So the first step here would be to isolate this guy by moving this over. So you're going to be left with the following. Because that's negative, remember this always has to be positive. Always positive. Okay, therefore no solutions, because it will never be negative 3 because it can't be negative. Okay, that's what I outlined in what I did over here, okay, in the solution. So when you take a look at the practice problem 4, okay, your first step, isolate absolute value. This is the first step in any equation. It just so happens that when you take a look at practice problem 3, it's already isolated for you, right? It's already isolated for you. Okay, so you always have to isolate it first, which will give you 4x minus 5 equals negative 7. Right away, that's negative. This is positive no matter what. So therefore, no solutions. So keep that in mind. Now I'm just going to go through some quadratic expressions. Okay, so if you have a quadratic expression within the absolute value sign, so you can take a look at the examples. There's no difference in how we're going to approach this question. We're going to approach it the exact same way. It's just getting these conditions right here can pose a bit of a challenge, but since we're pretty proficient in our quadratics, we should be fine here. So the first step, once again, is to write out the definition. So we have x squared minus 3x equals x squared minus 3x. Then we have negative x squared minus 3x. Right? Well, the question is, what are these definitions? So we have to, or the conditions. So let me just write this over here, conditions. We're going to be solving x squared minus 3x equals 0, which is a pretty easy equation to solve. X is going to equal 0, okay, or x is going to equal 3. Now the question is, remember this is a quadratic equation, so what you're actually left with here is a point at 0 and a point at 3, okay? Remember this is positive x squared, which means it's going to be basically going like this. Okay, we know it's going to do that, okay, because the a, right, ax squared, okay, a here is positive. A is 1. So you know this happens. So where is this graph positive? Okay. I'm doing this graphically because I think it's very much easier, or very easy to do graphically. However, you can do this by plugging in values. So for instance, you can plug in values less than 0 and see what happens. And you're going to when you plug in values, say plug in -1, you're going to get a positive number. Okay, plug in -1. We're going to have -1 squared minus 3 times -1 equals 0. Here's the power of graphing, because you know right here this is going to give you 4. Forget about this equals 0. That's going to give you 4. That's positive. A positive value. And your another positive value is when x is greater than 3. Remember, this is 3, that's 0. And it's negative in between. So your condition is when x is less than or equal to 0, okay, or when x is greater than or equal to 3. Remember, 0 is included, okay? 0 or positive, okay, that's when it's 0 or positive. And the opposite condition is when you're in between, in between the values, okay? So hopefully that makes sense. Of course, you can do it without graphing, or without sketching. You can plug in values to the left and right of both of these x-intercepts, and then you'll see if it's positive or negative. But I think graphically is pretty easy. So from here, we're going to do our cases. Case 1, case 2. Case 1 is x squared minus 3x equals 2, which we're going to solve this following quadratic. Let's see if we can do this by guess and check, or by decomposition, whatever you want to use. Our factors are 2 and 1, which that's what we come out to be, okay, which doesn't appear to work because we need x equals -3. Sorry, we need x equals -2, which -2 times 1 is +3. So let's just plug this into the quadratic formula and see what we get. So we're going to have, if you forget the quadratic formula, it's minus b plus or minus the square root of b squared minus 4ac all over 2a, which will be negative, so it'll be +3 at the end. And we're going to have 9, because that's -3 squared, minus 4 times 1 times c is -2, all over 2 times 1. I'm going to erase this case 2 here, give me some more room. So what's this come out to be? This comes out to be x equals 3, and within the discriminant we have plus or minus square root 17 all over 2. Okay, and we don't know if that's a solution yet. We can check. I'm going to convert them to decimal form so we can check. So first of all, the first decimal form we'll use plus 3 plus square root 17 divided by 2 comes out to be 3.56 with a bunch of decimals. And then the other one is 3 minus square root 17 divided by 2 equals negative 0.56 with a bunch of decimals. Now, both of them satisfy the first equation. Okay, they both do. This is greater than or equal to 3. This is less than or equal to 0. Okay, so now we have to go ahead and check if this is actually a solution. So if you check if this is a solution, what you're left with is the following. Absolute value of 3.56 squared minus 3 times 3.56 equals 2. Is that true? Well, that's 3. Let's see. When you plug this in your calculator, it's going to come out to be a solution. Let's see here. Yes, so that works. And then the next one you have to check is the following, which also comes out to be a solution. So these are your solutions right here. However, we're not finished. Okay, we have to go through and do case 2. Okay, we have to go through and do case 2. So remember, case 2 is negative x squared plus 3x equals 2. And in this situation, you're going to have x squared, moving everything over to the right hand side here, minus 3x plus 2 this time, which means we can finally factor it very, very quickly. And we will have 2 and 1. So we have x equals 2 and x equals 1. Okay. Now, both 2 and 1, these both satisfy the equation, so once again you have to check for these guys. And when we check for these guys, 2 will work, so x equals 2 will work, and x equals 1 will also work. So therefore, here are your solutions to this question. X equals 2, x equals 1, and x equals 3 plus or minus root 17 over 2. Okay, long question. However, the solutions present themselves very naturally. Okay. Now the last question, so it's a long video here, but the last question is solving a more complicated quadratic expression. Okay. And this is how we're going to finish it off. Okay. Solving these expressions will be the same as usual. Okay, we're going to take a look at the definition, and I'm going to do this one a bit more quickly. And in this case, it's if x is greater than or equal to negative 5, then you're going to be in business, and x is less than negative 5. Okay, so there's your conditions. So going along with case 1, you're going to have x minus 5 equals x squared minus 8x plus 15. Okay, in this case, we're going to have x squared minus 9x, okay, plus 20 equals 0, which we can solve, and it looks like we can solve it through factoring, which is always nice. Okay, 5 and 4, negative, negative, x equals 5, x equals 4. Does this both of these satisfy. Okay, so they both satisfy the condition of greater than or equal to -5. When you check, so you check this, you're going to be left with 5 minus 5 equals 5 squared minus 8 times 5 plus 15. Okay, which is, do you have 0? Is that going to equal both sides? Here we have 25 minus 40 plus 15, which is correct. Yes, it is. Checking the next solution, we have 4 minus 5 equals, so we have 4 squared minus 8 times 4 plus 15. So this is going to be an absolute value of -1. So we're going to have 16 minus 32 plus 15, which also, this one comes out to be -1. However, this is 1 equals -1, which doesn't work. So therefore, the only solution here is x equals 5. Okay? So x equals 4 is not a solution. Moving to case 2, we have x with the negative. And we move on to the following. -x plus 5 equals x squared minus 8x plus 15. So we're going to have x squared. This time we're going to have -7. And this time we're going to have plus 10 equals 0. Now 5 and 2 will give us our solutions. 5 and 2 minus and minus, x equals 5, x equals 2. Now we can immediately get rid of x equals 5 and x equals 2 because they both do not satisfy the conditions. Okay, so our solution is only x equals 5. So let's wrap up this video. Hopefully solving absolute values makes sense. You could have skipped ahead of the video, you can move around and come back to this if you are going over some of the practice problems, and you can see some similarities in some of the questions. So try the practice problems, and then when you're ready, move on to section 7.4.